Good afternoon. My name is Sergeant Yarosov. I'm with eLUXE3D, and welcome to today's webinar and a demonstration of the eLUXE3D jewelry scanner. It is just a few minutes away. We're going to get moving and showing you guys a live demonstration of the DS3 Gold Scanning System. It is one of our premier products for jewelry scanning. So we'll give it another couple minutes, let some people join, and we're going to get moving. This webinar will be recorded and will be shared in the future. So if there are any questions, definitely we can follow up in the very near future. So let's give it another couple minutes and we'll get moving. Thank you. Okay, let's get this thing started. Again, my name is Sergeant Yarosov. I'm with eLUXE3D. With me is Chris Glazier. Chris Glazier is the Vice President of Sales and Marketing. Some of you may have interacted with Chris in the recent past, and I'm sure you'll be interacting him with in the near future. So today we're going to go through a demonstration of the eZScan 8 software platform and running the three-dimensional scanner by eLUXE3D, our DS3 Gold system. We're going to show a pendant being scanned in multiple orientations and registered together, and ultimately exporting out an STL file. Before we get to that actual live demonstration, I want to show you guys a few slides, just go over a couple technical aspects and trying to better define and make sure you guys understand the concept behind our 3D scanning principles and philosophies, and the differences between traditional laser scanning versus structured light scanning. So for those of you who are not familiar with three-dimensional scanning, the two primary forms of 3D scanning are considered laser scanning or structured light scanning. Laser scanners tend to have a sweeping red or a blue or maybe even a green line that's automated or sometimes manually operated with some sort of an external coordinate measuring machine, usually a fixed line that sweeps along the part, and that acquires point cloud data, which is ultimately turned into an STL or polygonal model. Our technology is a little bit different as it works in a structured light fashion, so it's a megapixel based system. It works just like a digital camera. So your iPhone or your traditional digital camera is a 5 megapixel, 10 megapixel, maybe a 40 megapixel system that acquires images in 2D. Our technology has the same principle and philosophy behind that, but it collects images in 3D. So what that means is we're able to project a fringe pattern onto the object, and the two cameras that are collecting or looking at the fringe pattern are defining the resolution and gathering the data in a three-dimensional fashion. So we don't have a lot of moving parts. The only moving parts that you're going to see is within the scanner is the platform of the swing that rotates and has a fully automated swing. So you'll see this live in just a minute. The two systems that we currently carry commercially are the RecScan DS3 Silver and the RecScan DS3 Gold. The two systems are basically primarily differences is in the resolution. The Silver system is a 1.3 megapixel system, and it is a USB-based system, collects 1.3 million points per shot. And DS3 Gold is the 5 megapixel system, where it defines a very high resolution, collecting 5 million points per shot. With that, you can kind of see some of the technical specifications. On the DS3 5-megapixel system, we do have and have developed two forms or two different versions of that. We have a 50 millimeter field of view and 120 millimeter field of view. We initially had just a 120 millimeter field of view, and when I say field of view, what that means is how large of an object the system can see within a single scan. So 120 millimeters is the maximum, for example, on the large field of view. With that, we developed a 50 millimeter field of view, which is a very high resolution system, primarily targeted around high detailed objects, detail-rich objects such as engagement rings, some high resolution stones that have a lot of features. So it's really specifically designed for rings and very small objects that are within that 50 millimeter field of view. The DS3 Silver, the 1.3 megapixel system, is a fixed field of view of 100 millimeters, so it's about a 4-inch field of view. Covers, I would say, 95% of the jewelry applications out there that we encounter, bracelets, all the way down to some smaller objects as well. So we'll show some examples of the resolution differences on an STL file so you guys understand that a little bit better. Some of you may be wondering how large is this system, because you can't really tell based on just a presentation that you're seeing or a PowerPoint slide that you're seeing. But they're microwave size, maybe a little bit small, like a half a microwave. So they are desktop-based systems. So it's not a very large system. It is utilized in a desktop-based application. One of the advantages that our systems do carry is that we have an open STL platform, so we don't lock you into specific software that are out there, but don't necessarily have any digital models. So this gives us the opportunity to provide you with a digital model of some of the precious stones or precious pieces that have a lot of history behind it. Custom fit wedding bands is a very popular one. This process has taken a 3, 4, 5 day process down to less than a day process. In 3 to 5 minutes, we're able to capture a perfect 3D model of that engagement ring, which gives you the opportunity to build that wedding band with a perfect fit. It really saves on the iterations of 3D printing and design iterations. So it's something that's becoming very popular. 3D heirlooming, digital heirlooming, again, another format of use for our technology, and having old existing pieces that may have been passed down to family members within the generations of families now can be replicated or can be actually stored in a digital format, as you know, they have some family history behind them. So it's something that a lot of our customers are doing. This slide here will show you just a simple ring that was scanned with the 1.3 and a 5 megapixel system. So the image on the left is the 1.3 scan, and the image on the right is the 5.0 megapixel scan. And I'm talking about the single image that's on the left-hand side of the screen. So you can see that the resolution with that 5 megapixel system is a little bit sharper, a little bit crisper, which is defined by the triangles in the lower right-hand image. Again, to us that have been around the scanning industry for a very long time, this is something that we can clearly see. But to somebody that's just looking to acquire data very quickly for template purposes, for design purposes, the 1.3 megapixel system is a great system. So you can kind of see the correlation between the two data sets. Just a few samples for you guys of STL models, and we are seeing here on screen our STL models that are created from our scanner. So everything you're seeing are basically triangulated and fully watertight models. Here's a ring that was scanned with a 5 megapixel system. You can see the detail and resolution. It's able to pick up on those prongs and how sharp and crisp those come out. Some old coins that were scanned in. Again, the detail is really something to pay attention to, because it's preserved very, very nicely in a polygonal format. These are actually just basic stones, if you will, but just wanted to show the actual capability and how much detail we're picking up. If you did have some sort of an irregular stone that you needed to design around, We understand it's a very difficult process with some traditional calipers and tracing methodologies, but we have the ability to provide a very detail-rich model for you to work with in your CAD packages. Again, some 3D printed glass rings, a key, just some samples. This was kind of a cool project we did for a local university here. They just wanted to see if we can scan this was actually one of those helicopter leaves from a maple tree, just to see what kind of detail we're able to get. So that is showing both sides of the actual leaf. You can see all the veins in it very crisply. This was done with a 5 megapixel small field of view, 50 millimeter field of view. So kind of gives you a real world scenario of what the capabilities are. And of course, adding any sort of accessories to existing commercial products, that's kind of a big market for some of you out there. The ability to take an existing product that's been launched and design some accessories around it. This is just the Samsung watch, I believe, that was done with our 1.3 megapixel system scanner. So a lot of what we're talking about here is STL-based, STL format-based. For our purposes at eLUXE3D, we are heavy users of Geomagic simply because we've been around it for a very long time. Geomagic Wrap in particular is a platform that we utilize for cleaning up STLs, for having the ability to fill in holes, extract features, and actually creating NURB surfaces. It's a product that's been around for a very long time and has developed a lot of great tools for being able to work with high-resolution STL models. A lot of our customers use a combination of ZBrush, Rhino, GenVision Matrix, 3Design, a few others that are out there. But we're kind of, we want to put enough tools in front of you to understand what you can and can't do with the technology and what the limitations are. Because if you think about how much data we're collecting millions and millions of polygons, and there are certain CAD packages that are not designed to be able to handle this type of geometry. So we're always working with our CAD suppliers, CAD vendors to improve on their processing side. But for our immediate need, our go-to product is Geomagic on the reverse engineering side and on the inspection side. As I mentioned, it has a lot of polygon sculpting and cleanup capabilities to get you that watertight model. Just a quick snapshot of our contact information. We'll drop this screen back up after the live demonstration. Both Chris Glazier and I could be contacted at any time for any additional questions. So if you give me just a quick minute, I'm going to switch over to the scanner with a live demonstration of the product. So we'll get right back on in about a minute here. Thank you. Okay, we're back. Successfully was able to transition from one piece of software to another, so that's always a good start to the day. As you guys know, technology doesn't always behave perfectly, but I think you should be able to see a webcam showing the actual platform of the scanner itself, and then in the background, or depending on your layout, you can see our product in the software format that we're going to be using to collect the data. So what we've done over the past couple of years is we've really focused on developing a software product and a hardware product that's very easy to use, it's very automated, that doesn't require a lot of technical expertise. eZScan 8 is a software platform that was recently launched in conjunction with the DS3 and the Silver and Gold systems, and we really were able to create a product that kind of follows a a process. So just to show you a little bit of the layout and how this product actually, or software is actually developed, on our left-hand side, we have basically our project tab, which is going to be our starting tab of where we're starting a new project or opening up an existing project. And then we follow a process. We have our scan tab, align tab, and merge tab. We really want to create a process flow that your technical people are using as you're walking through the scanning process. So anything that's within your scanning capabilities that allows you to acquire data would be under your scan tab. You can see this is a live feed. The left and right cameras are actually live right now. So if I do put my hand in there, you can see that it's actually picking up the data live. This little pendant that we're scanning is a little puppy. It's about an inch in height, so it's relatively small. It has some detail on it, and this is what we'll be working with today. Down at the bottom, as we're within our scan tab, we also have a process here that's kind of steps you through steps 1 through 7, 8, 9, if you will. This basically guides you through the operations that can be run through our scan tab. Connect and disconnect our scanner, calibration process, which is probably a weekly thing, takes about 3 minutes to do, and then we go through our scanning procedures here. So again, everything we try to do and develop is in the automated fashion. We have what's called auto scan, which we're going to be running. It's just a string of macros. We have a next 10 button, which is kind of unique to our technology, which the software automatically calculates the missing areas in the scan, and it will generate the next 10 paths. Or we have what's called add scan, which is just an individual scan. So if I click on add scan here, the system is going to move to a position that we're looking at currently, and it's going to take a single shot. And there's what we're kind of seeing on the screen from one orientation. Now you can tell that we've scanned some of the platform, the fixturing system that we currently use, or the fixturing that we're currently using is just some putty. The system does come with a ring jig. It comes with a full fixturing setup. But anything that'll just kind of fixture your object in a permanent orientation can be utilized to hold in place. Your object cannot be moving independently from the swing or the turntable. So what happens during the calibration process, we actually create an internal coordinate system that's saved within the calibration file. So every time we move this swing, it knows its previous position and it registers the data together. So one nice tool that I like to use here to kind of avoid scanning some of the turntable or the platform, what we're going to do is we're going to turn on what's called a clipping plane, and I may be getting into some of the technical aspects of stuff of the software, but it's kind of nice to show. So what I'll do is turn on our virtual clipping plane. I'm going to drop that clipping plane to right about there, and then we're just going to go ahead and hide that. Now as I run our macro, we're going to go through and kind of delete anything that's below that plane. So it really saves a little bit of time and cleanup and processing. So I'll go ahead and delete this group. And instead of doing an individual scan, I'm going to run through what's called an auto scan. And this is basically a macro of, I think, 12 to 14 positions that we have in this macro for demonstration purposes. So it's really hands-off. You set the part down, you fixture it, hit the play button, and let the software do its thing. There's no registration that has to be done on the fly. Everything is done automatically as far as scanning is concerned. Looking back in our left-hand side, we have a group 1 that's being created. So as we're running this macro, the software automatically creates a group. And within that group, you can see scans being populated, right? So we have scan 1, scan 2, scan 3. It basically follows with a date and timestamp, but those names could obviously be changed if needed. So we're scanning live right now, as you should see on the screen. This puppy being populated very, very quickly. I'm going to zoom in a little bit for you guys so you can see some of the detail. There are some waves in the actual design of this piece. The eyeballs are some sort of tiny little stones, but this detail that you're seeing, this orange peel that you're seeing on the puppy, is actually on the object. This is not scan noise or something like that. This is actually detail that was designed and into our piece here. So we'll let this finalize, and then what I'd like to do today is I'd like to kind of walk you through the full process and what limitations we have with the system and what we need to do in order to have a full 3D scan that might be watertight, if you will, right? Because as you may know that with non-contact scanning, it is line of sight based. What line of sight means is that what it sees, it will scan. So if I gently rotate this guy kind of upside down, you can see we're going to have some missing data simply because the scanner can't quite see that location underneath. So some objects, some very high detailed rings that have pockets or holes that are not visible to the naked eye in certain orientations, the scanner might have a hard time seeing those. But with multiple orientations, we typically are able to gather most, if not all, of the data. But that's just something for you guys to understand that, we're not seeing through objects. We're not seeing through the actual physical object. We don't see through stones. It is line of sight. So once exactly. So quickly, at this point, what I'm going to do is I'm going to delete some of this putty or their fixturing, if you will. I'm going to turn on my edit command. I'm going to use a free shape and a select. So what I'll do is I'll just kind of select the areas that I don't need and just delete them out. And if I touch on a little bit of our actual part, our puppy here, it's okay, because what we're going to do next is we're going to flip this puppy upside down and gather up and collect the rest of the missing data, and then walk through an alignment process. So again, we're doing this live. There are no tricks here behind what we're doing. We just want to get you guys to understand the full capability of the product. Very easy workflow. If you do put down the product for a couple weeks and you turn it back on, it's not something you have to reach for the manual. It's something that you will pick up automatically. So, which was kind of our key in trying to develop and streamline this process. I'm going to do a quick save as here, and we'll just call this Pup 1. I get in a habit of saving quite often, as you typically don't like to lose work, and in case there's some sort of a crash, you always have your file saved. Okay, so here's what we're going to do now. We have our group 1, which has probably 85% of our scan, but we are missing a little bit of this guy on the bottom. So what I'm going to do is I'm actually going to remove this platform from our scanner, from our jig, and I'm going to take this puppy off, and I'm really doing this live, so please be patient with me. We're going to just flip them upside down and fixture them back in. One thing I should have mentioned, which I didn't, we do add a little bit of spray on the object. With scanning technology, if it's very shiny, reflective, transparent, translucent, you do have to spray the object down a little bit, right? So it kind of takes that shine and reflectivity off. It's very common with most scanning technologies out there. We have several different forms of spraying down the object, whether it's a 3D scan spray, whether it's a mixture of a washable paint and an airbrush kit, and that's something we will definitely walk you guys through as needed. So right now I'm going to flip this puppy upside down, and I'm going to add just a little bit of spray to it. Obviously you won't be seeing that portion, but trust me, that's what I'm doing. Make sure I've got him fixtured in so he doesn't move. Okay. You might be able to kind of hear the spray in the background a little bit. And this spray that I'm using is it's actually a 3D scan spray that's developed by a company out of Germany called Helling. It adds about 3 to 5 microns of spray depending on how much texture you put on it. But it's a very, very fine spray that does not take away from your from the detail of your object. Okay, I'll go ahead and drop this guy back into position. Tighten up our fixture. And now you can see our camera are seeing a different view, different orientation. So at this point, I'm just going to go ahead and click on the auto scan button. Actually, you know, at this point, what I'm going to do is I'm going to take one scan because I'd like to predefine my my clipping plane again. And in order to predefine that clipping plane, you want to have one scan on the screen so you can kind of see where you're trimming with the virtual clipping plane. Otherwise, you might be taken away from your object. So I'm going to go back into my options, turn on my clipping plane, and you can see that I can definitely bring this up a little bit. And we're good there. I can delete group 2, and then I'm going to run auto scan, same macro. So the macros are basically kind of embedded in the product. You can create your own macro, and all a macro is a string of positions, a rotation and a swing. It's an XML file that could be edited. It could be generated within the tools and the options that we provide. It could be edited in just a notepad or some sort of a comma separated value format. But all it is multiple orientations and a swing in position. Once the actual swing moves, the scanner takes over and takes a picture. And now you can see we're kind of filling in the blanks. I'm running the same exact macro as we ran for group 1. As you can see, and on the left-hand side here, we have group 2 that was created, and all the individual scans that fall within group 2. Our next step is going to be to take group 1 and group 2 and align them together. And this is something we're going to do in this product as well. So as soon as this is finished, we'll clean up some of the areas that we don't need, and we'll align them together. All right, looks like we just finished the last scan. We're going through a quick global align. And there is our group 2 scan. Again, I'm going to go into our editing and just kind of delete some of this noise that was picked up during the scanning, whether it's the platform, some of the background noise. I am going to zoom in and nicely trim around this putty. And again, this putty is just one of multiple forms of being able to fixture the object down. Hot glue is used quite often. Our customers have developed some of their own fixturing systems. The system, as I mentioned, does come with a very nice ring jig. It's basically it's a mini vise with some rubber padding on the inside, so it doesn't really deform your object. Again, the goal is just to fixture the object in an orientation that will prevent it from moving during scanning. Okay, so now we have the bottom portion of our puppy scanned. To play it safe, I'm going to do a save as and overwrite the previous file. So we have that saved. Yes, we'll overwrite it. Now that our scanning is complete, we're going to go to the next phase, which is our align phase. So as I click on the align phase, our cameras disappear. Now our icons down here at the bottom also change, and now we have a couple forms of alignment that we're going to be able to work with. I'll go ahead and turn on group 1, so you can see that we have 2 groups of scans that are in different orientations. And then we have a couple different alignment options here. We have a 1-point alignment, a 3-point alignment, a manual alignment, and then a global alignment. These are very standard alignments that you guys may have seen in other CAD packages. So 1 point is most common that we use. It's a very nice form of alignment. You just click on one common point and the software will take over. 3 points will allow you to pick 3 common points. Manual alignment will allow you to just rotate one of the objects on a screen manually. And then a global alignment is basically a curvature-based global registration that we'll do as a final step to ensure all the individual scans are globally registered. So what we do here is we click on the group that we want to move. So I'll make group 2 as my movable object. I'm going to click on that, and I'll click on 1-point align. This breaks up our screen into 3 orientations. We have our blue, which is our movable, which is in the upper right-hand side. We have our white model, which is our fixed model, which is in our lower right-hand side. And then on the left side, we have our blue and white showing us what the actual alignment is going to look like when done. So with the 1-point align, the only thing you have to be concerned about is that you have these objects approximately in the same orientation in 3D space, right? So I basically have the puppy approximately aligned in the same orientation in both views here, and we're going to click on one common point. So I'm going to click on kind of like this little neck area here. This point is approximately there. The software takes over and then looks for the overlapping information, and if you can kind of see on our left-hand side, based on our view orientation and the common curvature between the two, it snaps them together very, very nicely. It gives you a little bit of a distribution chart here, giving you an error and the distribution deviation, how much the actual objects have moved when aligned. So we're within about 8 microns is the average distance along all these scans. We'll click enter, and yes, we want to apply those changes. So now if I look at my 2 objects, 2 groups of scans, they overlap quite nicely. One final thing I like to do is do what's called a global alignment. So we just did an alignment based on individual groups. I'm going to click on this little finger up here, deselect all, and actually I'm going to say select all, and then click on global alignment. What global alignment does is actually takes over all the scans on an individual scan basis and does a final global registration, kind of bleeds through in case there was any vibration or in case I bumped the scanner or bumped the desk or something of that nature. It just tightens everything up. So you can see that we went from approximately 8 micron distance to down to about 3-4 micron as the average distance between scans. And you can see the colors, how they bleed through in a format that tells me that this is a very good registration and I'm happy with it. So at this point, we're going to go ahead and save this again. And then we're going to walk through the final step, which is our merge. So we're going to go to our merge tab. And merge is basically exactly what it states. We're going to merge these objects into one individual STL. Right now, they are still all based on 2 groups with about 15 or 16 scans in each group. I'm going to go through and select both of these groups, click on the merge object, and then we have some tools here to work with. Some of the tools that we kind of select or predefine are strictly based on our merge resolution and file size. File size is linked to basically your how large of an STL you'd like to have. So the way this works here, for example, my default merge resolution or the triangle edge length or point distribution is about 25 microns, which is pretty good. Most printers, you guys are printing at about 10, 15, 25 micron settings, so that's pretty good. And then our output file size is going to be a medium. So we're going to decimate this from approximately, if you look in the lower right-hand corner, 13 million points we're going to get rid of approximately 65-75% of that data. So still keeping the resolution of our data intact, not losing any detail, but really minimizing how large our file size is. And you can input a custom value here as well based on percentage. So we'll just go with default and medium. We'll go ahead and execute that. We'll say yes because we have saved this. And now it's going to take a minute or so, or maybe hopefully less than a minute, to merge this together. In case you guys are wondering what kind of machine I'm running on, I have an off-the-shelf HP ZBook with Windows 7 with an Core i7 processor. So, we do need some power, some horsepower between a laptop or a desktop. We do run on Windows 7 or Windows 10. But something that's off the shelf, that's you typically run your CAD system on, would be sufficient to run the scanner. Graphics card is important, good processor is important, and obviously the RAM distribution is relatively important. Yeah. So one reason I like to save the files as I go along is obviously in unexpected crashes every once in a while do happen. So you want to make sure you preserve your work. Second of all is once you finalize your alignment and you have gone through the merge step, you can see that now we just have one group and one file. So we've merged all of those scans together. And you can no longer go back and add scans, right? So we're actually now going to export out an STL or an OBJ file in this phase. If you ever wanted to go back and add additional scans, you really have to do it on the raw metadata file, which is an extension of MDT. That's our raw file format, and that will allow you to add additional scans, additional orientations. So with file management, as our customers get familiar, they typically save the raw file format, export out the STL file. Once they're happy and working on the STL file within their downstream process, you can go back and delete the original file, the original metadata MDT file with all the raw information. So in a nutshell, that's basically the process of scan, align, and merge. At this point, we're going to say export, and I'm just going to say export STL with OBJ, PLY, a couple different formats. We'll drop this on the desktop again. And that will kind of bring us to an end of the demonstration. There are additional tools that we didn't cover in here, some of the advanced tools that mentioned going through and creating your own macro settings. We do have some decimation tools in here if we, for example, just to kind of walk through some mesh repair tools, smoothing, deleting of clusters, decimation, manual hole filling. So we do have some tools that will allow you to massage the data or clean up the data once the scan is complete and once the merge is complete. But it's just part of some of the advanced training that we'll walk you guys through in the future. Chris, if there's anything else you want to add, I'll go ahead and flip over to your contact information. Very good. Well, thank you guys for your time. Again, that's Chris Glazier, VP of Sales and Marketing with eLUXE3D, and my name is Sergeant Yarosov, and we appreciate your time today. And if there are any questions, please jot down the contact information, get in contact with Chris, and we'll be happy to answer anything that you may have. Thanks, guys. Have a wonderful day.